Welcome to this first basic attractors tutorial with a focus on single point attractors. In this video, we will be using Rhino and Grasshopper to create a regular pattern of circles which decrease in radius based on proximity to a single attractor point which is sketched in Rhino. In this tutorial, you will learn how to set up a basic attractor using the distance component, how to limit values to a certain amount using the minimum or maximum components, and how to use the gradient parameter to color objects based on a color gradient. Let's get started. So we are going to start out in this first step by setting up a regular field of circles. And to do that, we are going to use the hexagonal grid component. So here under the fourth tab, vector grid hexagonal, we'll drop that on the canvas, and let's make our grid be 12 cells in the X direction. I'm just going to limit this slider, double click, and I'm going to make the maximum value there 30. It doesn't really matter, we're not going to get up to 30 yet, but let's just do that. And then the extents Y, I'm just going to copy this slider, Control C, Control V, plug that in, and now my extents Y, let's just try 15. So we have a 12 by 15 hexagonal honeycomb here. Let's just make it a little bit wider, just to fill the screen there. Okay, so I also want to set the cell size. So currently they're set at 1. I could use a variety of factors here, but I'm just going to set it at 2. But I want 1 point of precision. So double click, and I'm just going to type 2.0, and that will give me a slider with 1 point of floating precision for that. And I can go up to a maximum of 10, but we're just going to keep it at 2. Okay, so let's just zoom out to have this honeycomb filling our field. Now you'll remember that on the hex grid, each one of these cells has a center point, and we don't need to find the center point with the area component because the grid centers are automatically produced by this P output. So I can just drop a point container here under parameter geometry point that will feed those points in. And each one of those points, I'm just going to draw a circle to get us started. So here under the fifth tab, curve, primitive, circle. And we're using the basic circle component with a radius. So the radius, the default value is 1. We're going to be changing that soon, so we're not going to bother updating that yet. I'm just going to turn off my hexagonal grid, and let's just keep the points on for now because they'll be useful in the next step. So once I have my basic starting field of circles, now I want to start to create my attractor. So an attractor is a method whereby the size of geometry will increase or decrease based on its distance or proximity to one or more attractor points. So in this example, we're doing a single point for our attractor, and that point is something we want to be able to move, and it's something that we're just going to draw in Rhino and then reference into Grasshopper. So here in Rhino, I'm going to select the single point function and just draw a point anywhere. I'm just going to put it here in the bottom leftish quadrant. And what we want to do to reference this geometry into Rhino is we're going to come here under the parameters tab and select the point parameter. Remember, this is geometry that is coming into Rhino or from another source that is then used in Grasshopper. So it's orange because there's no data there currently. So to select that point that we've just drawn, I'm going to come here into Rhino, right-click this and say Set One Point. And then if I go over to my Rhino window, it's asking for a point object to reference. And then I'm just going to select that point. And you'll notice that I didn't need to push enter or anything. It automatically did that for me. And now this point is green in the Rhino window. And when I select the point container in Grasshopper, that becomes green again. When it's deselected, it's red. Just in case you have trouble seeing that, I'm just going to quickly draw a circle. You don't need to do this with a radius of 3. And so if you are having trouble seeing that point, there it is. And as I move that around, you can see that that circle I'm drawing in Grasshopper will follow the reference geometry around. Okay, just to make it clear that this is my attractor point, once I get more stuff on the screen, it might get lost. I'm going to select my point container, right-click, and put this into a group. I'm going to select the group, right-click that, and change the color to red. I like to have my input parameters red. This is something I learned from somebody else a number of years ago. And then I'm also going to right-click that, and here at the top, just type in attractor point. So that's just a way to label objects conveniently so that they don't get lost in the spaghetti that we're going to be creating. So a detractor, again, basically is based on the distance between each of these individual circles and this point, we are going to set our radius. Now, so that should give you a clue as to what component you need to use, or a component you could use, and it has to do with measuring that distance. So here under the fourth tab, under vector, point, we actually have this distance function. I'll show you in the next example a better way to do this, but we're going to use the distance here because distance is going to be quite helpful in a number of situations. So what does distance do? It measures the distance between a first point, point A, and a second point, point B. So our point A will be our attractor point. It's not that important the order you put them in, but then the point B will be each individual point in our field of circles. Now before I forget, I'm actually going to come here to my hexagonal grid output points, and I'm going to right click that and select flatten, because that hexagonal gridded geometry with the columns and rows isn't that important for this example. In fact, it's not important at all. So we're just going to flatten that so that it gets rid of that underlying data structure. Now, so I have my distances, and if I drop a panel onto the canvas, you can actually see what those are. And it's basically between the tractor point and each one of these points, and Rhino Grasshopper starts counting at the bottom left. So this is point 0, 1, 2, 3, 4, 5, 6, 7, 8. So 0 is 17, 1 is 14. So it starts to go down. Then it starts to go back up as we get to this corner. And then as we continue, it'll go up here, here, here. So somewhere on the list, we're going to get values around 2, 1. So 0.64 is probably one of these around here. So each individual point has its distance, and we're going to be using those as a way of setting our circle radii. So once we have our distances, we are going to use those to set our circle radii. Now, if I just take the distances as they are right now, and I plug them into radius, we start to get this mess. But you will notice if you zoom out that there are bigger circles here, smaller circles here, because basically those distances are already informing our circle size. They're just much too big because it's using the distance. So for example, this bottom corner, the point was a distance of 17. Let me just turn these off. This was 17, so this circle here is 17 units big, which is quite a big circle, and then the circles are basically too big. So if we actually just take this distance and use a simple division, so here under the second tab, Math, Operators, Division, and let's just divide it by a factor. Let's just start by dividing it by 10. So I'm going to just double click and type the number 10. Actually, just type 9.9. And that will give me a slider between 0 and 10. You'll notice when you get to 0, this turns red, which is an error state. So we don't want it to divide by 0. So let's just make this minimum 1. And so this will take these distances and then make them much smaller. So let's turn those circles back on. And instead of using this distance, let's use the distance divided by 10 as our circle radius. So you can see it's already starting to be a nice attractor pattern. And the circles here in the bottom corner, let's just turn, we'll keep that on for now. The circles here in the bottom corner are quite small, and then they increase as we get to this corner, and then they're starting to overlap. But if I come here into Rhino, my attractor point, remember that this point right here, if I move it, you will see that our pattern is updating based on where I put that point. So yeah, it's starting to look quite nice, and it's starting to do more or less what we want it to do. You can see here as I change my slider, those circles will start to get big. And let's just actually double click this slider again, and we'll make this max 20. And you can see, let's just make the max actually 30. That at some point they are they're not overlapping anymore in the top corner. But then the circles here are very, very, very small. So I'm going to actually rename this from B, and I'm going to rename this to circle scaling factor. And I could just right click that and put it in a group just to make it red, which will mean this is one of my parameters that I can change. Now, so if we want to have relatively, not too small, but circles like here that start scaling up here, but then at a certain point they stop scaling so that they're not overlapping, that's what we're going to try to address in the next step. So now we have our circle radii being informed by the distance. We have them scaling nicely up from our attractor point, and as we move away, at a certain point they start to overlap with each other. Depending on your goals, maybe this is okay, but we actually don't want them to overlap, and we want our circles at a certain point to stop scaling, basically to set a maximum circle size. So to do that, we are going to come up here under the second tab, Math, and then the final sub-tab under Math, Utilities. There are these two tools, minimum and maximum. So we want to send our maximum circle size. You might think you need the maximum tool, but actually you need the minimum tool. Because basically what we want this to do is we want it to return the smaller of two numbers. Now here the circle radii are quite small, but at a certain point it's around a radius of around 2, which was our initial hex size of our hexes. It's actually slightly more than 2, but around 2, what we want that to be is our maximum circle size. So if we take our distances here, let's just put these into a panel just so you can see what they look like. If we take our distances here, so we have this one here, 1.9, but as we go down the list, we start to have some quite small distances. These are those smaller circles in our pattern. I'm just going to keep this on for now. So I'm just going to feed that into A, and then I'm just going to set up a slider, double click, and I'm going to call this slider 2.0, which will be a number slider between 0 and 10 with a 1 point of precision, and I'm going to use that for item B. So what this is doing is it's returning the smaller of those two items, and I'm just going to do a panel right there, and you can see already, and we just scroll down to item 59, just to try to get the same frame here. There we go. So you can see here, any value over 2 gets replaced with 2 using this minimum component, but any value under 2 stays based on this distance factor. So I'm just going to plug those in for my circle radii, and suddenly I have this cap. Actually, they start to overlap a little less than 2. So let me just drag this down to around 1.6, 1.7, and that's where they start to touch. So you can see here that the circles start to scale up, but then once they reach that threshold, they will stop scaling. So now that I see this, I actually want my scaling radius to be slightly bigger. And so I'm just going to increase that factor as I go up. I'm going to actually rename the factor because now I know a little bit better. I'm going to call it circle scaling fall off. And fall off is usually something that has to do with a gradient or an attractor. So let me just turn off these points here. And so we have our circle fall off, and as I decrease that, we have less of an effect as I increase that. And I'm just going to actually rename this to attractor fall off. And if I come back here into Rhino, and if I start to move that point around, you can see that this fall off is moving with it. You can already see that this might actually be even more interesting if I had 2 attractor points. Now, if we have 2 attractor points, it gets a little bit more complicated, which we'll look at in the next example. And also this distance function will no longer be useful for us. But we're getting ahead of ourselves. For now, we just want to finish this particular example by coloring all of our circles, but instead of just giving them one color, we're going to color them based on a gradient. So now we want to color our circles based on their size, which is also based on their distance from this attractor point. And to color our geometry, we first have to convert our geometry into either a mesh or a surface. We're going to do a surface. So here under the 6-tab surface, surface freeform, we have the boundary surfaces component, and this will make them into something we can add a color to. So the default color is this pink color. We will want to override that, and we're going to start off doing exactly as we did with when we want a single color. We're going to come here under Display, Preview, Custom Preview. and we're going to plug that in for the geometry. And for this material though, remember before we came here under parameter input swatch, and we gave a color like that. So next to swatch though, you'll see quite close is this gradient, which is another way to add a color commonly. And so let's just drop this onto the canvas, and we're going to eventually use that to replace this brown color. So our gradient is running from, let's just make this red. So our gradient is running from light pink to dark red. And so basically we want our circles which are closer to the point to have a color in this range, the light pink range, and the circles which are further from the attractor point to have a color in the dark red range. So you'll see that there are three inputs on the gradient tool: a lower limit, an upper limit, and a T. So I'll explain T in just a moment, but lower limit is basically once we have these small radii close to 0, that will be our lower limit. And then once we have these large radius circles close to 2, that's going to be our upper limit. So we can actually use this maximum radius parameter that we've used before, and we're going to plug that into the lower limit, the upper limit. So any circle that is the size 1.7 will get a color towards this end of the gradient. And for the lower limit, we could use the lowest value in this list, but we also know that this is very close to 0. So to simplify things, I'm just going to draw a panel here and make this panel 0. So now we have a number between 0 and 1.7. So things that are closer to 0 will have a pinkish color. Things that are closer to 1.7 will have this reddish color. Now, what are we going to use to base this on? Well, it's going to be based on this radius. So here, the T parameter is the individual parameter for our individual pieces of geometry, which is going to inform which color they get. So I'm going to plug this radius in for T, and now I'm ready to use the output of this for my color instead of the swatch which I'd drawn earlier. So now I could delete that, and now I have this nice gradient between the lighter colors towards the attractor and the darker colors further away. Now, if you don't like this particular color, there are a number of ways in which you can edit your gradient. The first is here in the top corner. You right-click, and then there's these presets. And these are preset gradients, the dark green to the light. And I can click one of those. One of those. So let's go back to our this one. The second one is there are these dots. And if I hover my mouse over a dot and I right click it, I can change the hue of that particular dot. So let's say I wanted to go between kind of a light greenish yellow here, and then this second dot, I'm going to click that, and here I want kind of a dark green color, and so I can set those colors manually. Now you'll notice that this particular gradient has 2 dots in it, and if I change the preset, I can right click that, and some of these presets, for example, this one has 3 dots, this one has 5 dots, And so if you want gradients between kind of a rainbow between red and orange, orange and yellow, etc., you can basically do whatever you want with those. So let's go back to our first preset, and we'll just change those to yellow to dark green for that particular example. Just a few other things. I'm just going to turn the previews for these off so I don't have those edges. And yeah, so that's our basic script. Now there's another way I could set these values here. I'm just going to show you this as one final thing, and it's slightly cleaner. So if I have these surfaces here, actually I could use the area component to measure the area of my circles. I'm going to right click that to turn those points off. But I have basically area between a certain range. And if I come here under Math Domain and I use this bounds component, I can see, and if I hover my mouse, I can see what is the smallest size of a circle and what is the largest size of a circle. So those are my bounds. And I'm going to then take this domain and deconstruct it using under Math Domains deconstruct domain, which will give me the start and the end of that particular numeric domain or range. And so I can use that start as my L0, the end as my L1, and now I'll use the individual area as what's informing my color. So here I'm not having that spaghetti kind of going back, so it's just a slightly different way of doing it, but also a little bit cleaner, and yeah, I prefer to do it that way, to be honest. If you found this particular example helpful and would like access to a completed version of this script along with 2 others, you can go over to my website, Generative Landscapes, linked in the description, and download a copy of this for a small fee. And as a bonus for those of you who support this blog and channel, I have included a second version of this script which will allow you to insert to scale geometry based on multiple attractor points, which is all set up and ready to go. So if you desire to support me and this channel, please check it out. Thanks for watching.